everyone, and thanks for joining this discussion on medical payload security and quality assurance as part of Project CAELUS. Just to remind everybody, Project CAELUS is a research project part funded by Innovate UK. CAELUS stands for Care and Equity Logistics UAS Scotland. And the aim of our research project is to investigate and demonstrate the benefits and the challenges of implementing a logistics network based on aerial drones for the NHS and more broadly for the healthcare services. Now, as part of our research program, we have had some discussions with medical teams, as well as some surveys of the general public in terms of the key benefits and concerns that they have. One of the concerns is about the medical payload. How do we know that the medicine transported by drone will be fit for purpose at the receiving end? How do we know that the medicine received is the one that was meant to be booked? How do we know that the payload has not been tampered with in between? So in this little interview, we will try and answer some of these questions together with Richard. Now, Richard, can you tell us a bit more about Intelsius and yourself?
I can, yes. Thanks for inviting me along today, Annalie. So I'm Richard Merchant. I'm the Product Development and Engineering Manager at Intelsius. Intelsius are a healthcare packaging company supplying life sciences and particularly the distribution of pathology samples, as well as finished and investigative medicinal products. So Intelsius have been around for 25 years, rooted in or started in the BSE crisis in 1998, and we've built globally over that time to develop a portfolio of sample transport packaging covering class 6.2 dangerous goods, along with temperature control packaging for medicines, basically. We're based in the UK as our headquarters, as well as having global sites across US, India, Ireland, Germany, and Malaysia.
Good. Thank you, Richard. And let me introduce you to the Drone Office. My name is Annelies Calieres. I'm a partner at the Drone Office. I started investigating the requirements of transporting medical products by drones back in 2019 with an international lab company. And then we continued working on that topic as part of other research projects funded by Innovate UK, one being air response. We developed standard operating procedures for intermedical sites drone delivery. The second one was InMed, where we looked into further details on the requirements to get approval from the authorities to transport dangerous goods by drones. As a way of introduction to this discussion, maybe we can share the philosophy that is driving us. In essence, we consider that logistics by drone will be a form of transport like any other form of transport, and as a result, it will comply with all the regulations and best practices that are currently applicable in healthcare and healthcare logistics. And we would even say that we should strive to improve compliance and improve quality assurance with the use of new technologies. So with Richard, in the next minutes and going through the next slides, we will provide an overview of the key regulations identified for drone logistics. And we will share with you the best of our knowledge in terms of how we can respond to those requirements using drones. Now, obviously, this is a field of innovation, so engagement and feedback is very much welcome. You can respond or post comments on the Commonplace platform. You can also use the email address hello@projectcaelus.uk to offer comments or feedback. So, Richard, can you walk us through the rules that apply to the transport and distribution of medicines?
Yes. So to make sure that the efficacy of a drug is still maintained throughout any distribution network. We've got to sort of monitor that payload. And the reason why we monitor that payload is that we need to report into people like the Medicines Healthcare Products Regulatory Agency, or the MHRA, about how the materials have been moved about within any sort of network. So that could be from distribution hub to dispensing pharmacy, or that could be anywhere within sort of the logistics network. So there's a set of rules which are here, thank you. So the rules are stating basically that irrespective of the mode of transport, that we are able to demonstrate that the medicines haven't been exposed to conditions which are outside of the requirements of the drug. So we've got to make sure that the product integrity is maintained throughout. So we can do that in numerous ways, but usually that's making sure that we've got a qualified packaging system, making sure that we're monitoring internal, external temperatures, as well as sort of tracing those shipments, making sure nobody's interfered with it, and making sure that there's sort of a series of SOPs or operations manual which people are following to ensure that each shipment is done correctly.
Okay, so that was for medicines. And maybe now I will mention the notion of dangerous goods and how it applies in the context of logistics for the healthcare system. So first, what is dangerous goods? Dangerous goods are materials that are identified as such under the UN model regulations. So the UN, United Nations, have issued some model regulations back into the 1950s, and they have identified and classified all the different materials that could present a danger. And the danger, the risk here, is not so much in reference to the patient, but more in reference to the handlers, the public, or the environment. What if that substance is exposed, for example, to the handlers, or exposed in the public in case of a, I don't know, in case of a crash, for example. So if we look at the different dangerous goods that could be transported for applications in the healthcare industry, there are maybe three main categories. The first one would be the toxic substances, class 6.1, because a number of medicines, whether they are liquid or toxic, could be classified as those two numbers you see, UN 1851 or UN 3249. And this, for example, would apply to some cytotoxic medicines for cancer treatment. Another bucket of dangerous goods that we can see in user cases in the medical environment are classified as infectious substance, class 6.2. These would be blood samples, for example, because unless and until they are tested, we don't know whether there could be a pathology within the blood sample. Therefore, in doubt, they are classified as dangerous goods. The third bucket of dangerous goods that could be transported are the lithium batteries. We all know that we have lithium batteries pretty much everywhere in our lives, smartphones, PCs, but also in medical equipment, starting with defibrillators. Therefore, it's one of the key categories that we have to consider when we look at the types of dangerous goods that could be part of medical payload using drones. Now, the regulations, now that we've described what could be the dangerous goods on board the drones, the regulations applicable are what we call the DGR, standing for the Dangerous Goods Regulations. They are a set of rules developed by IATA, which is the International Association of Transport operators, so crewed aviation, manned aviation, and they've been developed over decades actually, but they would apply, actually the general philosophy would apply in the same manner to drones being transported by air. Now, it's important to note that transporting dangerous goods by air is subject to a specific approval by the aviation authorities. In the UK, that authority is called the CAA. Now, Richard, can you walk us through how you address those requirements, actually, starting with the dangerous goods, for example?
Yes, so for pathology samples, we're looking at class 6.2, and the packaging that's involved there follows a very basic sort of 3-layer packaging principle. So our primary, or our first layer of packaging, is the receptacle, so our tube, our 30mm universal, and then that gets packed into what's known as a secondary. So in this instance here, that's our Pathopack 1 litre bottle, and that bottle needs to be sort of leak proof, as well as make sure that we can withstand pressure differentials. And then external packaging there is our third layer, and that needs to have sort of relevant information printed on it. So this is a category A box, so on there we have a UN number printed on there. We also have the relevant markings and labellings for the system, and then also people like responsible persons, contact details, recipient, sender, as well as a list of contents that needs to be included there. Under IATA, packaging systems for UN 3373 need to undergo drop testing from 1.2 metres, and packaging for class or category A materials, they're dropped from 9 metres, as well as undertaking some stack and puncture testing. So that's sort of our packaging for pathology samples. Similarly, for packaging for devices containing batteries, they'll need to go through their testing, as well as those for class 6.1 toxic materials, but all in a similar manner. Okay, so I guess the final question is how's CAELUS going to meet all of these requirements which we've spoken about? So first and foremost, we want to make sure that this packaging is secure. So we've got a locking device within the packaging. We also want to make sure that the temperatures within there are being monitored. So we've got some onboard temperature monitoring capabilities. So that will take an internal temperature as well as an external temperature. So we'll know how the external temperature affects the insides of the packaging and the payload temperatures. We'll also have different ways of making sure that the product payload is kept at the correct temperatures. So different medicines and different blood products need to be maintained at different temperatures. So 2 to 8, 15 to 25, and -25 to -15. We've got all the coolants and the necessary materials and knowledge to make sure that that's maintained, as well as making sure that that box is insulated, because what we don't want to do is let sort of the external temperature affect the internal temperature of our packaging. And then finally, we've spoken about sort of the temperature and all the rest of it. What we want to do is make sure that this is sort of future facing with the technology, and the device is transmitting the information wirelessly. So you'll have a tracking portal where you can actually see what the temperature is on board the drone whilst in flight, as well as then generate the relevant quality reports that come out at the end of it for auditing, and to make sure that the people that we mentioned right at the start of the presentation, the MHRA, are happy with how we are moving materials in our drone network.
Thanks, Richard. Brilliant. You know, it's really good to understand, to have that comprehensive overview of the requirements that will be applicable to the transporting of medicines and medical payload by drones, and how we can address those requirements.